is tool life, tool wear, and machinability. And we have seen what is tool wear and what are the types of tool wears or the locations of tool wear. That is crater wear and flank wear locations wise. Then we have seen the mechanisms of tool wear. So mainly due to adhesion, abrasion, okay, and many other are there. Adhesion, abrasion. Then we have the oxidization. Those are the other mechanisms. Okay, diffusion. So there are many mechanisms. Then we have seen the tool life also, Vt power n equal to C. Okay, that equation, and it mainly depends on speed. Tool life mainly depends on speed, but okay, it depends on other parameters also to some extent, like feed and depth of cut. So that is the Taylor's tool life equation, and we have understood what is machinability. What is machinability is ease of being machined. Okay. Machinability of a material is defined as its ease of being machined. In simple words, now that can be quantified as a machinability rating. Okay, what is machinability rating? Speed of machining the work. Okay, giving 60-minute tool life. So if you are getting 60-minute tool life, what is the corresponding speed divided by 60 for 60-minute tool life for a standard material? What is the tool life? Now, what is that standard material? It is a steel material. Okay, there are many steels actually. So medium carbon steel, you can say, into 100 will give you the machinability rating. And we have seen the indicators for good machinability. Okay, cutting force should be low, tool wear should be low, tool life should be high, etc. And how to improve machinability also we have seen just by varying the chemical composition. Okay, suppose one material doesn't have good machinability. Now by adding few other materials, can you improve its machinability? Like sulfur, small quantities. Okay, if you are, then its machinability may increase if you are adding sulfur to steel, etc. Now microstructure improvement or refinement of the microstructure. Okay, if the grains are large, machinability may not be good, so you make them small by heat treatment processes and any other treatments also. Okay, you can try to improve the toughness. Toughness should be less anyhow, but good machinability, toughness should be less. Ductility should be increased. If the material is hard, try to increase its ductility by some heat treatment process, etc. Now let us see some problems related to tool life. So all of you take your calculators, pen and paper. These are not difficult problems as I told you earlier. Vt power n equal to C. That is the equation, main equation. That's it, we can solve easily. So all of you try to do. So this we have seen. So here, look at this. A better surface finish is desired in a workpiece. I recommend 3 steps without involving tool change. So qualitatively, I mean, by varying some machinability parameter, parameter related to machining process, how will you improve the surface finish without changing the tool? Any answer?
Heat treatment of workpiece.
What?
Heat treatment of workpiece, sir.
Heat treatment of workpiece. Mm,
I mean, such that the grain size becomes
okay.
less.
Okay. That is an indirect way. Its impact on machinability. We are not talking about machinability. We are talking about surface finish. Of course, surface finish and machinability are a little bit related. Okay, your answer is giving the indirect okay answer. You are giving indirect answer. That is fine, but concentrate on surface finish. Directly on surface finish. How can you improve the surface finish?
Sir, adjusting the rake angles, speed, and the
Okay, speed is one thing. Rake angle, we can rake angle is one answer, but here it is directly given. Recommend 3 steps without involving tool change. If you are talking about a rake angle change, that means you are changing the tool, or at least you are grinding the tool. You are not, okay, don't touch the tool. That is the thing. So speed variation is one thing. Okay. Now, should you increase the speed or should you decrease the speed?
sir increase the speed, sir.
Yes. Okay. So like that, see, that is the first answer. Any other thing?
Sir, applying coolant oil, sir.
Yes, that is also there. But till now, we have not talked much about the coolant application. Yes, application of cutting fluid is definitely one answer. Here we are mainly talking about speed, feed, depth of cut, okay, these things. So decrease the feed, increase the speed, decrease the
Sir, and
feed.
decrease the depth of cut, sir.
Yeah, that will also be one answer. Decrease the depth of cut. Of course, definitely cutting fluid application will okay, generally give good surface finish. But as of now, we have not talked about cutting fluid and its okay impact on the machining process. So speed, feed, depth of cut. Okay, these are the almost okay. When we are talking about any machining process, these are the 3 most important factors. Now, what is the impact of speed on surface finish, on material removal rate, on power, etc.? Okay, you should be aware of. Similarly, what is the impact of feed? What is the impact of depth of cut on any machining characteristic? Okay, these 3 are main. Remaining cutting fluid application or tool material, workpiece material, these are all secondary. Now look at this problem. Following data has been obtained in a tool life test at 2 different cutting speeds. If 0.3 mm width of flank wear land is the selective failure criteria, calculate the value of N and C of Taylor's tool life equation. So some experimental data is given. 0.3 mm width of flank wear land. Okay, that is selected as the failure criteria. This is a standard thing only. Now this is the data. Now how will you proceed? You are given the time and speeds are given. Let us say 150 meter per minute is given. So at 0 time, there is no flank wear. It is obvious. After 10 minutes, if you are using 150 meter per minute, it is 0.1. If you are using 200 meter per minute, it is 0.17. Similarly, if you are using 20, it is 0.14 and 0.27, etc. Now we are taking the criteria of 0.3 mm. Okay, flank. So where is 0.3 for the first speed? So it is obviously
60 minutes.
60 minutes. So for the first condition, that is if you are using 150 meter per minute, tool life is 60 minute. That is the information. Now what about the other tool? Not other tool, other condition. At a 200 meter per minute, so it is somewhere between 20 and 30 if you see. Okay. At 20, you are getting 0.27. At 30, you are getting 0.37. Now at what speed you will get? 0.3. So for this, you have to do interpolation. How will you do that? We are assuming linear relation between time and this flank wear land. That is the assumption. Now how will you do this? You can just draw a graph. I mean, you can imagine a graph with the time. Just so this is time. So this is flank wear land. Okay, you give some name, flank wear land. I think there is a standard term is there, but anyhow, if you don't remember, you can write it. Okay, for example, I am using flank wear land as F. So you draw this graph at 0. It is 0. So let us say something like this. It is increasing. Okay. Now write that equation. Find the slope. How will you find the slope for this line?
We consider 2 points and then y2 minus y1 by x2 minus
Yeah.
x1.
Find out, all of you do this on your notebook. Not only finding out the this thing, you find out the equation. Equation for that line I have drawn. How will you find the equation? Y equal to mx plus c. In this case, directly mx only because there is no c. Okay. So what is y? Y is flank wear in this case. Okay. M into x is a tool life, let us say. Now find out m first. Tell me what is m. So in case of I am representing flank wear as f. You clearly write, okay, flank wear is equal to f mm. Okay. Otherwise, if you are using this f, we will think that this is a feed rate. M slope, okay, slope of the line. That is m.
Sir, M is 0.3, sir.
0.3. Is it same for all other students also? At least some of the other students. Just we can re-verify because I have not done any calculation here. So x is a tool life. So all of you agree? Is it 0.3 or any other value somebody has got? Delta y by delta x, that's it. So this is a 0.1. How much is this? 0.01 divided by 10, isn't it? Is it 0.3?
If we apply a slope for 20 and 30 time, we are getting 0.01, sir.
Yeah, it should be 0.01. No? Just please re-verify. It is 0.01. Is it 0.01 or more? 0.001.
No, sir, 0.1 only, because 0.1 by 10 we'll be getting, sir.
Yes, 0.1. Okay. So it is 0.01. Okay, just re-verify. Or if you have any doubt, you just ask me how you have got 0.3. Maybe by mistake, I guess. So that's it. Now, we know that 0.3 is the flank wear for failure criteria. So if F is 0.3, F is the flank wear land. So it is 0.1 into T. Now what is T? What is the corresponding T value? Is it 3 we are getting?
Yes, sir.
Some mistake. Flank wear land is 3 we should not get. It will be somewhere between 20 and 30 minutes.
Sir, I was getting 23 minutes, sir.
Sorry. Just wait. How do you? Okay. We have not considered this, no? Yeah. 0.3 may be correct. Let us see. So what is slope? Slope only we have to see. 0.27. Yeah. I don't think there is an issue in slope also. It's clear. Yes. What is x? Corresponding x value is 30 minus 20 is 10. This is fine. This is a meter per minute. Okay, anyhow, slope doesn't have. This is in minute. It's at 200. One thing is here, this is in mm, isn't it? This flank wear land value is in mm.
Yes, sir.
Okay, all these values are in mm. So now tell me, anyhow, m will not change. Feed is a 0.3. Sorry, not feed. Where this is 0.1 only. Now T we are getting as 3. But it should not be 3. We are getting as 3. Now what is the unit?
In minutes we'll be getting, no, sir.
Hmm?
In minutes, I mean, like flank wear is in slope is in per minute, no, sir.
Slope is in mm per minute. Uh, okay, per minute. Yes. Flank varies in mm. Okay.
Or, sir, maybe we can, I mean, like consider a point. We need, I mean, we can compare slopes between
There are actually, tell me.
30, 0.37 is 1 point, no, sir. I mean, time and feed if we
Hmm.
take. Uh,
Yes.
and 20, 0.27 is 1 point.
Yes.
Like that, if we see, uh, okay,
Hmm.
1 minute, sir, I'll verify and I'll tell actually.
So somebody has told it is 0.3. How you have got 0.3?
No, sir, it was wrong, sir. Not
Hmm.
point 3, it's point 1 only, sir. Actually, I was doing directly by interpolation, like equating the slopes.
Okay. Okay. So this method is correct, but somehow why we should definitely get somewhere between 20 and 30.
Sir, I was getting 23, not means that the point 0.3 slope value, but
Hmm.
applying that, equating the slope formula.
Equating the slope. Yes, yes. Yeah,
Yes,
that
sir.
is right.
X minus 0.27, sorry,
Hmm.
0.3 minus 0.27 upon 0.37 minus 0.27 equated to x minus 20 by 30 minus 20.
Hmm.
So
Yes.
while rearranging, we will get x is equal to 23. That's the
Yes, sir,
test.
if we do like that, we're getting 23 minutes.
Yes, yes. Now, how? Okay, that is the correct approach. But what is wrong in this method? Should-
No, sir. Our slope is correct, sir. We are
Slope is
getting
correct.
point 0.1.
Okay. Yes, slope is correct. Okay. I mean, why this? Both should be same, no? What is the difference? I am not getting both approaches. But anyhow, whatever you have done is correct. I agree. So equate the slopes. Maybe, I mean, mathematically, is there any mistake here? I am not getting. Okay. So equate the slopes. So you are getting 23 minute.
Yes, sir.
So is it clear to all of you? Any doubt here?
No, sir.
Okay. You are getting 23. Now it is done almost. So here, what is the thing? 0.3 with the flank land is selective failure rate. Calculate the value of N and C. Okay. So for the first case, 60 minute is the tool life. For the second case, 23 minute is the tool life. Okay. So you know velocity and tool life. So here also you know velocity and tool life. Okay. So now you take that equation Vt power n equal to C. So for the first case, V is 150, T is 60. You are getting two equations, that's it. Yeah, power n equal to C. So you can take logarithm here because you have this power. Okay. And similarly, in the second case, velocity is 200 and corresponding tool life is 23, power n equal to C. So you have two equations, two unknowns. You solve these equations by, okay, any method, doesn't matter. Both sides you have C, you can equate both the equations and find out n. Okay. So find out n and C. If you have any doubt, please ask me.
N we are getting 0.3, sir.
Okay, fine. C. Simply put n value in one of the equations.
512.3, sir.
512.3.
0.3.
512. Any of you other guys, please check. N and C values have got the same. Any other?
Yes, sir. Yes, sir.
Okay. So that is how you will solve this problem. Main thing is getting this 23 is important. So for that purpose, you are equating the slopes. Okay. I hope it is clear. If anybody has doubt, please ask now. Now next problem is this. A tool life of 100 mm is obtained at 25 meter per minute and 6 minute at 70 meter per minute. So it is very straight problem. Tool life is 100 for this 25 meter per minute. So T is given, V is given. Similarly, and it is tool life is 6 minute at 70 meter per minute. Now what is the tool life equation? Find out. So how will you find tool life equation? So they are asking for, we know that it is Vt power n equal to C. So in the first case, velocity is 25 time 100. Same thing, whatever you have done just now. Power n equal to C. That is one equation. Similarly, it is a 70 and 6 power n equal to C. You solve these two to get n and C values. Okay, and once you get n and C values, you will put them here. That is your tool life equation for the given cutting tool. Find out n and C.
Sir, N I got 0.366, sir. And C is 134.8.
Okay, n equal to 0.
366.
Okay, fine. Will be in that range generally, somewhere around 0.3, 0.4. C equal to
134.8, sir.
134.8. So once you get any value, generally you think about its range so that you will come to know. Generally, n varies from somewhere 0.1 to 0.5 in that range for any material. We have seen that list for different materials also. So it is within the range means our method is, anyhow, this is simple thing only. Anything. Okay, for any value, force value, or anything, you think about the range after getting the value. Okay, so these are n and C values. So you will put them here and that is the solution for part A. So you will now write V T power 0.366. Here I don't have writing pad. So equal to 134.8. That is the tool life equation. Now what is the cutting velocity? And tool life is 1. So you can find out what is the tool velocity, very straightforward. V
134.8.
yes, because T is 1, so it is directly 134.8. Now C, what is the cutting velocity for tool life? 60 minutes. So you substitute T as 60. So V 60 power 0.366 whatever and 134.8. So what is V?
30.12, sir.
30.12 meter per minute. So that's it. Here in two life equation, I mean, these problems are simple. They are definitely dependent on Vt power n equal to C equation only. Okay, so this is the thing. Now let us see this. So how do we solve this? Following is the record of number of identical components produced at different spindle speeds and feeds between the consecutive tool changes. So in a single pass Stirling operation, estimate the number of components that can be produced at a spindle speed of 350 RPM and feed of 0.15 mm per revolution. So data, look at the data, N, F and number of components, that is M is given. So at 250 RPM and 0.1 feed, okay, for a single tool, we can produce 311 components. Okay, 311 components can be produced before the tool fails. Similarly, at 250 RPM, but feed is changing as 0.125. So before the tool fails, okay, tool fail criteria is there, whatever it may be 0.3 flank average flank wear. So you can produce 249 components there. So in the third case, so 300 RPM, feed rate 0.125, you can produce 144 components. Now the thing is, estimate the number of components that can be produced at a spindle speed of 350 RPM. So here it is 350. Feed is 0.15 mm per minute. Now what are the number of components? Is the question. Now how can we solve this? Any idea? We know Vt power n equal to C. So what is V? V and n, what is the relation?
V equal to pi d n by 1000.
Okay. So V is proportional to n, directly proportional to n. Because, okay, if all others are constants, we'll take, so Vt power n equal to C, instead of Vt power n equal to C, if diameter, other things are constant, okay. So we can write, and of course we have Vt power n because we are talking about feed also. In this problem, feed is also given. So it is not simply Vt power n equal to C. Some F is also there in between. Let us say F power M. M is already given here. Vt power n1, F power n2, let us say, equal to C. So instead of V, we can put N. And now there is no information directly available for T in the given table or any other description also. Now, is there any relation between M and T?
1 by m equal to 1 by t, sir, or t equal to 1 by m. I mean proportional.
Inversely proportional you are talking.
Yes, sir.
No, it is directly proportional. How? Because if you let us say time is increasing, you have more tool life. So you can get more components.
Yes, sir, understood.
Okay. So in place of V, we will write N. In place of T, you will write M. And remaining power N1, F power N2 equal to C. Understand? So now using this equation, you substitute these three sets, 1, 2, 3, and find out N1, N2, and C. Do this. So this is the original Taylor tool life equation. We have modified it, not modified, you can write still V equal to pi d power n, but pi d all are constant, you can strike out all those. So this is the another version of the same equation. Find out n1, n2, and c values by using this okay, these three data, whatever is given. You can find in different ways directly, because you have scientific calculators you can do. Otherwise, you can apply logarithm, so you will get equations. Okay. Like if you are applying logarithm here, it will be log n, capital N, plus n1 log m plus n2 log f equal to log c. So you can put those values and you will get three straight line equations. Okay, so based on that, you can find what is log m, what is log f, what is log c. Then, okay, you will take the anti-logarithm, that is m equal to e power something. Let me find out if you have found these values, please tell me. N1, N2, and C. So all of you should do. Okay, only one or two are responding. Others should also do, and because if you do here, your work is done. Okay, you will remember this. If you are simply sitting silent, then you have to work later. Anybody has completed? So anyhow, I'll leave it here because I have given the procedure. So N1 and 2 C you will find. So once you know that, you can put 350 and 0.15 in the equation and find out the corresponding M value. Okay. So if M is in fraction, let us say it may be some 70, 0.5, etc. So obviously we will say we can produce 70 components. Okay. 0.5 component is okay. That is not completed. Only half of the component is machine. Okay, let us proceed. So this is a more simple problem. In a tool life test on turning operation, following data has been obtained at a depth of cut of 2 mm. T, V, F are given. So what is the equation? Vt power N1 F power, because F is also given. So F power N2 is equal to C. Am I audible?
Yes, sir.
Yes, sir. Yeah.
Yeah. So using this equation, so you find out N1, N2 and C. Straight away data is given. Okay, three unknowns, N1, N2 and C. And you will get three equations. You will find N1, N2 and C. So then obviously with the given V value, given F value, and C value, you can find out the T value. That's it. Okay, there is no complexity here. And so that's all. Okay, for today's class. Okay, so we have solved the 4 problems. So there will be problems like this. All problems will be mainly dependent on that same equation. Whenever you are seeing something related to tool life, so it is always Vt power n equal to C, or F and D may also come into picture. So, but okay, these problems are simple but very important. Okay, so let us stop here. And one thing is, we have our mid-exam on Monday. So mid-exam syllabus, okay, it is already informed through CR. Just I am repeating. So tool geometry, that is the first topic. Chip formation, chip mechanism of chip formation, second topic. Then mechanics of metal cutting. Okay, in that we have seen merchant theory and different other things, shear angle, etc. Then cutting tool materials and thermal aspects. So these are the 5 topics for mid-exam. So it is for 30 marks, and as per the given time in your timetable, I think it is 2 hours time. So we'll stick to that. And you will have some 10 to 15 short answer type questions, descriptive, all descriptive. Suppose some 2 marks question, some 3 marks question will be there. Okay, it is a mix of numericals and theory questions. So we expect straight answers. That means if you ask some question, you answer to that particular point only. Don't write too much other irrelevant description. Okay, and of course you have to write the essential portion. Okay, don't think that because you have asked for very straight answer, we have given only one word, one phrase only. That is not sufficient. You have to write the enough. Whatever is required, you have to write. And whenever you are writing, particularly whenever you are writing data, okay, if any problem is given, general procedure is you note down the data clearly. So in terms of known symbols, suppose side rake angle is given, or let us say principal cutting edge angle phi is equal to this. You have to write like that. Okay. Because that phi is used for shear angle also. If you simply write phi equal to this, there will be some confusion. So to avoid that, you have to write the okay, principal cutting edge angle comma phi is equal to these degrees. Okay, like that you write the data, you write the relevant equation, and you show the substitution and find out the corresponding value and write with units for any problem. Okay. And if any theory question is asked, you have to think about the what is the science behind this, what is the reason. Mainly we are interested in reason. Straight statements will also okay, will be there. Okay, because of increase in feed, okay, we are getting more force. This is known for all of us. Why force is increasing with feed, that is the main thing. Okay, in any question. So you think about the reasons and state those reasons very clearly. Scientific reasons you have to provide. So any other clarification required regarding today's class or regarding mid-exam?
Sir, midterm is on Tuesday, no, sir?
Yeah, okay. It is on Tuesday. Yes, Tuesday.
Yes.
What is this? Okay, Tuesday. Okay, all of you prepare well and do well in your mid-exams. Have a good day. So, of course, this weekend you have this Institute Fest also. Are you participating in this Institute Fest? Of course, it is online.
Yes, sir. Few students are conducting events.
This is anyhow we are missing the physical interaction, but okay, whatever is possible in this time. And of course, I think timing is not appropriate, I guess. Just before the mid-exam, if you are giving the fest, it is difficult. It should be immediately after the mid-exam, ideally.
Yes, sir.
Okay. Okay. So have a good day. I'm closing the session.
Thank you, sir.